Hello students, I am Manoj Kundare, the Assistant Professor of Electronic Science. Welcome back to our e-learning platform. In previous video, we have seen the instruction syntax and various addressing modes used in the assembly language programming of 8051 microcontroller. The link of the previous video is available in the description box. Please check it. Now, in this video, we are going to see the instruction set of the 8051 microcontroller. The 8051 microcontroller has the following types of instruction set: arithmetic group instructions, logical group instructions, data transfer group instructions, branch group instructions, and boolean group instructions. Let's see the details about the each type one by one. The first type is the arithmetic group instructions. In this group of instructions, all the types of arithmetic operations are performed, such as addition operation, subtraction operation, increment, decrement, multiplication, divide, and decimal adjust operations. Okay, let's see each type of operation in detail. Our first type of operation is, or the first group instruction is addition. The addition operation is further classified into two types: addition without carry and addition with carry. Let's see the first type, addition without carry. The syntax for this instruction is add a comma source byte. Okay, the function is addition without carry. In this instruction, the flags affected are OV means overflow, CY means carry, and AC means auxiliary carry. It adds source byte to the accumulator and places result into the accumulator. That means in this type of instruction, the addition of the source byte and the destination byte is happen, and after this addition the result is stored in the accumulator. Okay, let's see the examples here. The addressing mode, in immediate addressing mode, the syntax is add a comma immediate data, that means hash data. Okay, the function is the addition of the immediate data and the accumulator is performed and the result stored in the accumulator. That means here, for example, add a comma 30h, that means here the addition of accumulator and the 30h data is directly added with each other, and whatever the result of the addition is stored in the accumulator. The next addressing mode is register addressing mode. The syntax for this is add a comma rn. Rn means n stands for the number of registers, which may be 0 to 7. Okay, the function is the addition of register with accumulator and the result is stored in the accumulator. For example, add a comma r0, that means here the addition of a with r0 is performed and whatever the result of the addition is stored in the accumulator. The next addressing mode is direct addressing mode. That means the syntax of this addressing mode is add a comma direct. Here direct is referred as the RAM memory location. Okay, the function of this direct addressing mode is a plus direct. That means whatever the data is stored in this memory location is added with the accumulator and the result is placed in the accumulator. For example, add a comma 30h, that means the 30h RAM location has some data. This data is added with the accumulator and after the addition the result is stored in the accumulator. The next addressing is indirect addressing. The syntax for indirect addressing is add a comma at the rate ri. Here I is 0 or 1. That means we can use only r0 or r1 registers for the indirect addressing mode. Okay, the function of this is a plus ri and the result stored in the accumulator. For example, add a comma at the rate r1. That means whatever the data pointed by the r1 register into the memory is added with the accumulator, and after the addition the result stored in the accumulator. This is the only add operation. Now let's see the addition with carry. The syntax for the addition with carry is add c a comma source byte. The function is addition with carry. The flags affected are overflow, carry, and auxiliary carry. The function is it adds source byte to the accumulator with the carry and places the result in the accumulator. That means A is added with the source byte with the carry, and whatever the result of the addition is placed in the accumulator. Let's see the examples. The first addressing mode is immediate addressing. That means addition with carry add C a comma immediate data or hash data. The function is a plus immediate data plus carry. The addition of these three is performed and the result is stored in the accumulator. For example, a comma 30h. That means here the 30h data is added with the accumulator with carry, and the result is stored in the accumulator. The next addressing is register addressing. Add C a comma rn. The function is the addition of accumulator, the register, and the with carry is performed, and the result is stored in the accumulator. For example, add C a comma r1. That means r1 is added with the accumulator and the result is stored in the accumulator. The next addressing mode is direct addressing mode. That means the syntax for it is add c a comma direct. Direct is referred for the memory address. Okay, here the addition of the accumulator plus direct address is performed with carry, and whatever the result of the addition is stored in the accumulator. For example, add c a comma 30h. That means whatever the data stored in the 30h location of the RAM is added with the accumulator, and after the addition the result is stored in the accumulator. Next, the indirect addressing. Add c a comma at the rate ri. That means I is 0 or 1. The function is a ri with carry, and the result is stored in the accumulator. For example, add c a comma at the rate ri. That means whatever the data is pointed by the register r0 is added with the accumulator, and the result stored in the accumulator. That means in addition operation we seen the two types of information or two types of instruction, add and add c. That means addition without carry and addition with carry. For example, if we have add a comma 30h instruction, okay, then the after addition of 30h memory location data with the accumulator, the result is placed in the accumulator. Okay, I hope you all understand the addition operation. Now we have one example here. Move a comma hash 3fh 3fh. The next instruction is add a comma hash d3h. The question is that what is the value of carry, auxiliary carry and overflow flags after the second instruction is executed. That means we have this short very small program here, move a comma 3fh. That means this data is immediately loaded into the accumulator. After this instruction executed, the accumulator has the value 3fh. Then add a comma d3h. That means in first instruction the accumulator has the data 3fh, and this 3fh now added with the d3h without carry. Okay, let's see the operation here. 3fh means 0011, 3fh means 0011, and f means 1111. This get added with d3. D means 1101 and 3 means 0011. After addition we get the result 1 plus 1, sum is 0, carry is 1. We know that in case of 1 plus 1 plus 1 we have sum is 1 and carry is 1. 1 plus 1, sum is 0, carry is 1. Okay, 1 plus 1, sum is 0 and carry is 1. Again we have the combination 1 plus 1 plus 1, that means sum is 0, carry is 1. 1 plus 1, sum is 0, carry is 1. 1 plus 1, sum is 0, carry is 1. And 1 plus 1, in that condition also we have sum is 1 and carry is 1. Here the final carry is also 1. Our question is that what is the value of carry, auxiliary carry and overflow flag? That means the carry flag is set whenever the carry out from the D7 bit, and here is the carry out from the D7 bit. That means the final carry is generated, hence CY is set. Similarly, auxiliary carry is set when the carry is out from the D3 bit. Here the carry is out from the D3 bit, that means here the carry is generated, hence the auxiliary carry is also set. And overflow flag, that means here is the addition overflows to 9th bit, hence this flag is also set. Sorry, this flag is not set. I hope you all understand the addition process. Now let's see the subtraction. Okay, the next arithmetic group instruction is subtraction, and we have only one type in it, subtraction with borrow. The instruction syntax is SUBB a comma source byte. The function is that subtraction with borrow. The flags affected are OV, overflow, carry and auxiliary carry. It subtracts source byte with accumulator and places the result in the accumulator. That means it is opposite of the addition operation. Accumulator is subtracted with the source byte with the borrow, and the result is placed in the accumulator. For example, in immediate addressing, the syntax is SUBB. SUBB stands for subtraction with borrow. There is no SUB operation. Okay, keep in mind. SUBB a comma hash data, that means immediate data. This data is subtracted with the accumulator and result is stored in accumulator. For example, SUBB a comma hash 40h, that means this 40h data is subtracted with the accumulator and the result of the subtraction is placed in the accumulator. The next addressing is register addressing. The syntax is SUBB a comma RN. N means 0 to 7, R0 to R7. That means the RN is subtracted with the accumulator and the result is placed in the accumulator. For example, SUBB a comma R3. That means R3 is subtracted with the accumulator and the final result of the subtraction is stored in the accumulator. The next addressing is direct addressing. That means SUBB comma direct. This direct means the direct memory locations. Okay. That means the whatever the data is stored in this direct location is subtracted with the accumulator and result is placed in the accumulator. For example, SUBB A comma 60H. That means the whatever the data is stored in the 60H location of the RAM is subtracted with the accumulator and the result of the subtraction is placed in the accumulator. The next instruction is indirect addressing. The syntax for indirect addressing is SUBB A comma at the rate RI. That means whatever the data is pointed by this register is subtracted with the accumulator and the result is placed in the accumulator. For example, SUBB A comma at the rate R0. That means whatever the data is pointed by the R0 is subtracted with the accumulator and the result of the subtraction is placed in the accumulator register. I hope you all understand the subtraction operation. Now let's see the next group instruction, increment. Okay, the instruction syntax for increment is inc source byte. The function is increment. The flags affected in this instruction, there is no flag affected. It adds 1 to the register or to the memory location. That means it adds 1 to the source byte. Okay, the source byte plus 1. For example, increment ACC, that means increment accumulator, the syntax is INCA. That means 1 is added to the accumulator and result is placed in the accumulator. Example is INCA. Similarly, increment DPTR means DPTR is incremented by 1 and the result is placed in the DPTR. Okay. The next instruction or the addressing mode is register addressing. That means increment RN. RN is incremented by 1 and result is placed in the RN. That means INC R5. After this instruction, R5 is incremented by 1 and the result is placed in R5. For example, if R5 has the content 04H, then after INC R5, the R5 have the value, first it have value 04 plus 1. That means after INC R5 it has the value 05H. Okay. Similarly, in direct addressing, INC direct instruction syntax is used. That means whatever the data is placed in this direct address is incremented by 1. Okay, for example, INC 46H. That means 46H has the same has some data. This data is incremented by 1. The next instruction is indirect addressing, INC at the rate RI. That means whatever the data is pointed by this RI register is incremented by 1. For example, INC at the rate R1. That means whatever the data is pointed by the R1 is incremented by 1. Similarly, we can have the instruction decrement. The syntax for this instruction is DEC source byte. That its function is decrement and there is no any flag affected in this type of instruction. It subtract 1 to the register or to the memory location. That means in this the subtraction of 1 is performed. For example, decrement accumulator DECA. In this instruction, the accumulator is decremented by 1. Similarly, in DEC DPTR, the DPTR is decremented by 1. In register addressing mode, DEC RN, That means whatever the RN register have the data is decremented by 1. For example, DEC R5. That means whatever the data R5 has is decremented by 1. Similarly, in direct addressing, DEC direct means the direct address has some data. This data is decremented by 1. For example, DEC 46H, that means whatever the data has in the 46H memory location is decremented by 1. In indirect addressing, DEC at the rate RI, for example, DEC at the rate R1, that means whatever the data pointed by the R1 is decremented by 1. Okay, the next instruction is the multiplication instruction. Okay, the syntax is mul ab. A means accumulator and b means register. B register. The function is multiplication, and carry and overflow flags are affected in multiplication operation. It multiplies a with b and result store in both a and b. That means if a into b operation is performed, then the lower byte of the result is stored in the accumulator while the upper byte is stored in the b register. Okay. In multiplication, the carry flag is always clear while overflow flag is set when the product is greater than FFH. Okay. For example, if A is 50H and B is for A0H, then after MUL AB operation, that means multiplication of AB operation, we get the result A has the value 50H, B has the value A0H. Then after multiplication, we have the result 323200H. The lower byte is stored in the accumulator, that means 00 is H is stored in A, while the upper byte is stored in the register B, that means in register B we have the value 32H. Similarly, we can see the division operation. The syntax for the division operation is DIVAB. Okay. In this operation, the carry and overflow flags are affected. It divides A with B and the quotient stored in A and the remainder is in B. That means in A divided B operation, the quotient is stored in register A and the remainder is stored in the register B. For example, or in division, the carry flag is cleared while overflow flag is set when register B to indicate invalid result. For example, if A is 35H and B is equal to 10H, then after division of AB or after div AB operation, we get A has 35H, B is 10H. After division H, we get 03 as the quotient and 05 as the remainder. 03H, that means the quotient is stored in accumulator, and 05H, the remainder is stored in the register B. The next group of instruction is decimal adjust instruction. Okay, DAA. There is no carry flag affected in this instruction. This instruction is used after addition of BCD numbers to convert the result back into the BCD. The BCD stands for binary coded decimal. The add or addc instructions, the 8-bit data in accumulator get adjusted into BCD form by if the lower nibble of accumulator is invalid BCD, or if auxiliary carry is equal to 1, then add 6 or 0110 to lower nibble, or if the upper nibble of the accumulator is invalid BCD, or if the carry flag is 1, then add 6 or 0110 to upper nibble to make it the valid BCD. The DAA, that means the decimal adjust accumulator instruction, is used only after add instruction. It will not work after INC, that means increment instruction. For example, if A is 47H and R3 is 38H, then after add A comma R3, the instruction, the contents of the accumulator are A is 7FH. That means if A is 47H, that means 01004 and 7 means 0111. It gets added with the data 38, that means 0011, and 8 means 1000. Okay, after this addition we get the result 1 plus 0 1, 1 plus 0 1, 1 plus 0 1, 0 plus 1 1, 0 plus 1 1, 0 plus 1 1, 1 plus 0 1 and 0. We get the result here 7, and here is F. We know that 7 is the valid BCD and F is the invalid BCD. Hence, if we get the invalid BCD, then we have to add 6 into it. That means 1111 plus 0110. Or let's see once again. Here we got the result. We have to add 6 into it. 0110 is 6. Okay, we have 1 plus 0 is 1, 1 plus 1 is 0, carry 1, 1 plus 1 plus 1, sum is 1, carry is 1, 1 plus 1, sum is 0, carry is 1, 1 plus 1, sum is 0, carry is 1, 1 plus 1, sum is 0, carry is 1, 1 plus 1, sum is 0, carry is 1 and 1. We get the data 1000, that means 8, and 0101, that means 5. That means if in BCD addition we get the invalid BCD, then to make it valid we have to add 6 into 8. For that purpose we have to use the DAA instruction. I hope now you all understand the use of DAA instruction. Okay, thank you.